This indestructible home survives EF5 tornadoes. So why is it illegal to build? The storm doesn't knock, it erases. Whole neighborhoods disappear in minutes, walls ripped apart, roofs carried off like scraps. And yet, in the middle of that chaos, one structure stands calm and unbroken. No cracks, no collapse. Just a silent curve that refused to fail. That structure is called the Monolithic Dome, and it might be one of the most overlooked survival shelters ever created. Its story doesn't begin in a lab or a modern factory. It goes back thousands of years, long before blueprints or engineering degrees existed. Early humans, working with nothing but instinct, discovered that curved shapes could survive where flat ones failed. They bent bones, wood, and hides into rounded shelters, not for style but for survival. Wind passed over them. Weight settled evenly. These early domes stood firm while other structures collapsed. As civilizations advanced, that same principle was rediscovered and refined. Ancient builders realized something powerful about the dome shape. When you curve a structure into a full circle, force doesn't hit it in one place. It spreads across the entire surface. There are no weak corners. No pressure points waiting to crack. That's why massive domes built thousands of years ago are still standing today, while countless rectangular buildings have long turned to dust. But despite this ancient knowledge, modern construction took a different path. Straight walls were easier to design, easier to mass-produce, and easier to standardize. Over time, the world became filled with box-shaped homes, familiar, predictable, and deeply flawed when pushed to their limits. Then, in the 20th century, a breakthrough happened. Engineers and builders revisited the dome not as a relic of the past, but as a solution for the future. They experimented with different methods, trying to create a structure that combined the strength of ancient domes with modern materials. Early attempts like geodesic domes showed promise, but had one major flaw: too many joints. Every connection point became a potential weakness, a place where leaks could form or materials could fail. The real innovation came when builders developed a way to create a dome as a single, continuous piece. That's what makes the Monolithic Dome different. It starts with a circular foundation, anchored firmly into the ground. On top of that, a massive fabric membrane is attached and inflated using powerful air blowers. At this stage, it looks like a giant balloon rising from the earth, but this inflated form is only the beginning. From the inside, workers spray a thick layer of insulating foam across the entire surface. This foam locks the shape in place and creates a strong thermal barrier. Next comes steel reinforcement rebar, arranged in a grid that covers the entire interior. Finally, concrete is sprayed over everything, building up layer by layer until it forms a solid, seamless shell. No seams, no joints, no weak spots. When it cures, the result is a single piece of steel-reinforced concrete that acts as both the walls and the roof. One unified structure designed to handle extreme forces without breaking apart. And that design changes everything. In a traditional house, wind hits flat walls and creates pressure. Roofs act like wings, catching air and lifting off. Corners become stress points where damage begins. But a dome eliminates those weaknesses entirely. Wind flows around it instead of pushing against it. There's nothing for the storm to grab onto. That's why these structures have been shown to withstand the most violent weather on Earth, tornadoes that level entire towns. hurricanes that flatten coastal cities. In many cases, the dome remains standing with little to no damage while everything around it is destroyed. Fire is another threat that most homes can't survive. Wood frames ignite quickly. Flames spread through hidden spaces inside walls. But a monolithic dome is made of steel and concrete materials that don't burn. It doesn't feed the fire, it resists it. Then there's energy efficiency, where the dome quietly outperforms almost everything else. In a standard home, insulation sits inside the walls, separating you from the outside. But in a monolithic dome, insulation is placed on the exterior of the structure. That means the massive concrete shell inside acts like a thermal battery. It absorbs heat or cool air and holds it for long periods. The result is a stable indoor temperature with far less energy use. Heating and cooling costs can drop dramatically, sometimes by more than half. In some cases, the need for heating becomes almost non-existent. It's not just a house. It's a system designed to work with physics instead of fighting it. So with all these advantages, strength, efficiency, durability, you'd expect to see these homes everywhere. But you don't. And the reason has very little to do with performance. The biggest barrier is the system that controls how homes are built and financed. Most people rely on mortgage to build or buy a house. And mortgage depend on something called comparables. Lenders need to see similar homes in the area that have recently sold to determine value. Here's the problem. Monolithic domes are rare, and the people who build them tend to keep them. They don't sell often. That means there aren't enough comparable sales for appraisers to use. Without that data, lenders struggle to assign a value. And without a clear value, they won't approve a loan. No loan means fewer buyers. Fewer buyers mean fewer domes get built, and the cycle continues. Then come the building codes and zoning laws. Many areas have strict rules about how homes should look. Minimum roof pitches, standard shapes, neighborhood consistency. A dome doesn't fit neatly into those rules. Even if it's stronger and safer, it can still be rejected simply because it's different. Permits can become expensive. Inspections can take longer. Engineers may need to provide extra documentation because local officials aren't familiar with the design. All of this adds friction to a process that's already complicated. There's also the human factor. People are used to square rooms and flat ceilings. A dome feels unfamiliar, and unfamiliar often gets rejected even when it's better. But for those who push past these barriers, the benefits are hard to ignore. Maintenance is minimal. There's no roof to replace every couple of decades, no wood to rot or attract pests. The structure is built to last for generations, not just decades. Insurance costs can also drop significantly. A home that resists fire, wind, and structural failure presents far less risk, and less risk often means lower premiums. Over time, the savings add up. Energy bills stay low. Repairs are rare. The structure remains solid year after year. This isn't just about comfort. It's about resilience. The kind of resilience that matters when systems fail, when weather turns extreme, when the unexpected becomes reality. The monolithic dome represents something rare in today's world, a solution that's already been proven, already been tested, and already shown to outperform the norm. Yet it remains on the edges, held back not by its flaws, but by the systems built around something else. And maybe that's the real story here. Not just a stronger house, but a reminder that the best solutions aren't always the most common ones. Because when the next storm comes, and it will, the difference want to be in how familiar your home looks. It'll be in whether it's still standing when everything else is gone. If this kind of knowledge matters to you, real solutions, real resilience, then don't let it stay hidden. Share it with others who need to hear it. And if you want more insights like this, more forgotten designs that could change the way you prepare for the future, make sure you subscribe and stay connected.